This video is on cubic sequences. If you're still having trouble with quadratic sequences, you're going to find this difficult. You may want to first re-watch the quadratic video. While you're watching this video, I'm expecting that you're going to take notes on what is written and the example that I'm going to go through. So first, let's do definition. A cubic sequence is one in which the first difference is not constant. Okay, that would be linear. And the second difference is not constant. That would be quadratic. But the third is constant. So if you have that, then it's a cubic sequence. The general formula for the nth term in a cubic sequence, I know it looks overwhelming, is t sub n equals an cubed plus bn squared plus cn plus d. This should look similar to the formula that we had for quadratic sequences, except now we have a cubic term tacked onto it. So this one has 4 different terms, whereas the quadratic formula started with an squared and then bn plus c. So now we have that d term and we have our cubic term tacked on. So with these cubic sequences, the constant term, which will be that third difference, is going to equal 6a. So with our quadratic sequences, the constant term always equaled 2a. And here it's going to equal 6a. And when I do out the example, you'll see that. But this is how you're going to get a. So that constant term, when we get that third difference, whatever that number is, and it will often be a 6, we're going to set that equal to 6a to figure out what a is. To figure out b, c, and d, we're going to have to set up 3 different equations and solve them because we have 3 different variables. I'm going to do an example on the next slide. So here's our example, and it is an example for a cubic sequence, so this is definitely going to work out to have a third difference that's constant. So you might want to pause the video while you write down what you see so far, and then I'm going to go through the first, second, and third difference. So first we're going to find the first difference, and to find these differences you always do the second term minus the first, or you could say to yourself, what do I have to add to this term to get this term? So basically I have to add -2, or you could think -8 minus -6 becomes -8 plus 6, and so that number is -2. So the difference between -8 and -6 is -2. The difference between -8 and -6 is +2. I'm sure this looks like an interesting sequence, one in which we could not probably have figured out a pattern, right? It goes -6, -8, -6 again, and then 6, 34. So it's super random. But if we keep doing these differences, we will see that, in fact, the third difference is constant. So hang in there. Okay, on to my third and fourth terms here. So the difference between these two is actually 12. 6 minus -6 would be 12. And the difference between 6 and 34 is 28. So these are my first differences. Now I have to repeat the process, finding the second difference, which is the difference between the first differences. So I'm going to do the same process. Either say to myself, what do I have to add to -2 to get 2, which would be 4, or say to myself 2 minus -2. That's still 4. So that's the difference between the first 2 terms. The difference between the next 2 terms is 10, and the difference between the last 2 terms is 16. So that's my second difference. On to my third and final difference, because even though we only have 2 terms here, you'll see that the difference is constant. The difference between 4 and 10 is 6, and between 10 and 16 is 6. So remember that constant term, that third difference, is going to always equal 6a. So just from this alone, we can see that a must equal 1. Okay, so we already have a. We now need to go find b, c, and d, which I'll do on the next slide. Okay, so I've rewritten my sequence. I've written the general formula that I'm going to use to solve for b, c, and d, and I've written that a is 1. So now I need to use my sequence to find 3 different equations. So we did this exact process with the quadratic sequences, finding 2 equations. Now we're just going to have to find one more. It will complicate things a little bit, but it's the same idea. So I'm going to start with my first term, just like I did with the quadratic sequences. And since it's my first term, we know that n is 1. And so I'm going to replace all of the n's with 1 and a with 1, since we already solved for that. So this is now 1 times 1 cubed plus, we don't know b, times 1 squared, plus, we don't know c, times 1, plus, we don't know d. So there's a lot we don't know. But we do know that the first term, if you go back up to your sequence, is negative 6. So I now know that I can set this equation equal to negative 6. I'm going to clean this up just a little bit. 1 times 1 cubed is 1, plus b plus c plus d is negative 6. Or I could write, that's supposed to be an arrow, b plus c plus d equals negative 6 minus the 1, negative 7. So that's one of my 3 equations. And in fact, I'm going to label this as equation number 1. That will come in handy when we start organizing things. All right, now we're going to find information using the second term. So that's where n is 2. So since n is 2, I'm going to replace all my n's in my general formula up above here with 2, and I can still replace that a is 1. So it's 1 times 2 cubed plus b times 2 squared plus c times 2 plus d. Again, I'm just filling into this general formula that's up above. Maybe I should circle it so it stands out in red. Here's my general formula that I'm using. Okay, so back to our second equation down here. Since I'm using information for the second term, I can go up to my sequence and I can fill in that this second term equals negative 8. So now I can set this equal to negative 8. Oops, I'm still writing in red. Let me switch back here. And I'm going to clean this up now. So my second term is equal to 1 times 2 cubed, which is 8, plus b times 2 squared, which is 4b, plus 2c plus d, and that is negative 8. Or I could rewrite that one as 4b plus 2c plus d, and that equals negative 8 minus another 8, negative 16. So that's my second equation. Sorry that I'm running out of room here. And so I'm going to label that as number 2. Okay, we have to do this one more time. So now we're going to talk with n equals 3. So that's the third term. And so now for all of the n's, I'm going to replace them with a 3, and I'm still using that a as 1. So it's now 1 times 3 cubed plus b times 3 squared plus c times 3 plus d. And since it's my third term, I can go up to my general sequence up here, and I know that the third term also equals negative 6, and so I can set it equal to negative 6. We're going to clean this one up. And so we have 27 plus 9b plus 3c plus d, and that equals negative 6. Or I could put 9b plus 3c plus d equals negative 6 minus the 27, or negative 33. Negative 33. That is my third and final equation. And so I will continue this on the next slide. So you need to have these 3 equations to proceed. So I've rewritten my 3 different equations on this slide, and as I did it before, I've labeled them 1, 2, and 3. Again, I really think that will help as we start moving forward. So I'm actually going to now just work with equations 1 and 2. So I'm going to line those 2 equations up, and just like we did with the quadratic sequences, I'm going to use the elimination method to eliminate one of the variables. The easiest variable to eliminate will be d, because if I just subtract these 2 equations as they stand, the d's will eliminate. I'm actually going to subtract up. I hope that doesn't bother anyone. If you don't like it, you can subtract down, but I'll avoid some negatives this way. So I'm going to do 4b minus b. Instead of b minus 4b, I'm going to do 4b minus b. I can do that as long as I do 2c minus c, d minus d, and negative 16 minus negative 7. So as long as I do it with all of them, it's fine. 4b minus b is 3b. 2c minus c is c. D minus d is 0. And now it will equal negative 16 minus negative 7, which is negative 9. Okay, this is my first equation with two unknowns, and so I'm actually going to call this equation 4. All right, now I've worked with equations 1 and 2. Okay, so I've already worked with both of those, so I must include equation 3 now. But I have to line equation 3 up with one of these other two equations, and it does not matter which one. I'm actually going to choose equation 2, which might surprise you, because it's more complicated than equation 1, but when I go to subtract these things, I will actually get smaller numbers than if I used 9b minus b. Again, it does not matter. You'll still end up with the same result in the end. So I'm going to line up equations 2 and 3. So now I'm working with these two, and I'm going to put those down here. And so I have 4b plus 2c plus d equals negative 16, just rewriting them so that it's lined up nicely. 9b plus 3c plus d equals negative 33. So again, I'm working with equations 2 and 3, just like I did over here. I'm going to subtract the two equations, and the d's are going to eliminate. Like I did before, I'm going to subtract up. So 9b minus 4b is 5b. 3c minus 2c is 1c. D minus d is 0. And negative 33 minus negative 16 is negative 17. So that is actually my fifth equation. Okay, from here on out, it's actually something we've already done. So I'm now going to work with equations 4 and 5 because that's a system with two unknowns. So I'm going to line up equations 4 and 5. I will do that here. Sorry, this is getting messy. So we have 3b plus c equals negative 9. And the fifth equation was 5b plus c equals negative 17. And hopefully you're seeing that I'm now going to use elimination to eliminate the c's. I'm going to subtract up again. And so when I do that, 5b minus 3b is 2b. C minus c is eliminated. And we get negative 17 minus negative 9, negative 17 plus 9 is negative 8. And finally, we can get what b is. It's negative 4. So I now have my second variable. I still need to go find c and d. So since I have what b equals, I can go back to one of these two equations to find out what c equals. That'll probably be the last thing I can fit on this slide here. So we have 3. I'm using this equation. I could also use this equation, but this one has smaller numbers. So I'm going to do 3 times my b, which is negative 4, plus c equals negative 9. So that's 3 times negative 4 plus c equals negative 9. That's negative 12 plus c equals negative 9. And so c, if I add 12 to the other side, would equal 3. We are almost done. I now have b and c and a, if you remember. So I can go back to any of these top equations, substitute in my b value and my c value, and I can solve for d. Using this first equation will be the easiest. I know I've written a lot on this slide, but it might be easiest if I just finish this off in this bottom corner here. So, filling in my b and my c value into this equation, it's going to be b plus c, so that's negative 4 plus 3 plus d equals negative 7. Negative 4 plus 3 is negative 1. And so d turns out to be negative 6. Okay, we are basically done. So I have my a, if you remember from the beginning, was 1. and now I have B, C, and D. So on the last slide, I will wrap up our general formula. Okay, here are the 4 variables that I solved for. A was easy, and then we just solved for B, C, and D. Now I need to substitute them into my general formula for my cubic sequence. Okay, here's my general formula, and finally I'm going to fill in. My A value is 1, so that's just n cubed, plus negative 4n squared would be minus 4n squared, plus 3n, plus, negative 6. I guess I could have just written minus 6. So here it is, our general formula. As we've been doing in class and on homework, we should test this with our third term to see if we get the third term. And what was the third term? The third term was negative 6 if you go back to the beginning of your notes. And so when I substitute in, I'm hoping to get it equal to negative 6. So let's see, since it's the third term, n is 3. So we have 3 cubed minus 4 times 3 squared plus 3 times 3 minus 6. Okay, that's 27 minus 36 plus 9 minus 6. And we're hoping that equals negative 6. Well, this is negative 9. Plus 9 would be 0. Minus 6 would be negative 6. And that does equal negative 6. So, feeling pretty good that our formula works. I know that's a really long process. Don't worry, you won't have 10 of them. But here is the general formula for a cubic sequence. Probably not one you could have reasoned out just by looking at it. If you have any questions, please feel free to email me. That's it for this video.